Hi, my name is Ting Wei. I will explain our own design program execution, especially for my group, and also include the conversion from infix notation to postpaid notation, and finding the original expression by using state diagram. So let us start now. Our group design expression is this. You can take a look. X is equals to a plus b in the first bracket, then multiply with c in the second bracket, then subtract with e in the third bracket. Next, all of the result multiplied by f, and we subtract the behind, which is t minus b in the first bracket, and then the result multiplied by g before adding the h, and lastly divide by a. We need to figure out that the divide operation will be done before we subtract the front with the behind. This expression we also known as infix notation. So we proceed to the conversion it to postpaid notation. First, we need to clearly know that every operators which it add, subtract, multiply and divide are need to shift to right side. Let's start with the first operation. The first operation, which is a plus b. In this case, plus sign is the operator, so we switch it to right. So it will become ab plus. Done for the first bracket, then we do the multiplication operator similar to previous. We need to shift the multiple sign to the right. So it will become AB plus C multiply. Done for the second bracket. Then we continue to subtract E, shift the minus sign to the right side. It will become AB plus C multiply E minus. And continue doing the multiplication of X. Now, the answer for the front part is AB plus C multiply E minus F multiply. Now we're done for the front part. So, we proceed to the behind. The subtract operator here, we leave it for a while because for mathematical operation for this expression, we need to figure out the behind first and divide by A. Lastly, we can subtract the front with the back. Now, similar step, db, we shift d minus b, we shift the minus sign to the right side. We can db minus. And the similar step again, we shift the multiple sign. Shift the multiple sign of G to the right side. Then we add H. So shift the add sign to the behind. Then lastly we divide by A. So it will become like this. Now we haven't done yet. We need to shift the subtract operator to the right, become like this. AB plus C multiply E minus F multiply DB minus G multiply H plus A divided minus. So this is the final answer for the postfix notation for this expression. Now we continue with getting the original expression by using stack diagram. For this, we need to have a zero addressing for machine instruction to proceed further. Stack diagram is used a concept called last in first out. For example, the first instruction will be at the bottom and the second instruction will be on the top of the first instruction and will be operated first if any operation needed. So let us start now. We push value A into stack. Now done for the first instruction. Now we push value B into the stack. Now the bottom part we have A, value A, and the upper part we have B. Here we go. The B is on the top of A. So now we're done for the second instruction. We proceed to the next, which is add. We will not to move the position of A because B is on the top and it is first prior to be operated. So we add B. Since the operations is done, then the top value, which is B, has been combined with the bottom value, which is A. So it will become like this: A plus B. Then we continue to push the value C. A plus B at bottom, value C. Then we multiply it. Here we put the bracket to differentiate the operation done previously, otherwise it will mix and hard to expose. Then we push the value E. And then we subtract it. Now we push value F and then we multiply it. Now we continue push the value D. Also push the value B. So for now, you can see it is going upper and upper. Now we have subtract instruction. We only do for one time for operation, so we just subtract by value B with its bottom part only. So we have D minus B after operator executed. So this is D. Now we continue, push the value G. And then multiply it. and then push the value h. And then we add. Now finally we need to push value A and then divide all of this with A. Bracket to differentiate it. Now we have subtract instruction after divide instruction. It means that we need to use the top one to do operation with the bottom one. So we combine the top with the bottom with minus sign. So it will become like this. Lastly, we have pop X instruction. Pop instruction is just need to store the final value after done the operation. So it means that this result after operation will be stored in X. Now we can find the original expression with the step diagram. So that's all is about the step diagram, and thanks for your watching.